So this question is talking about a shape, and it's asking us to work with a starred question, so therefore we're going to be having to explain things really clearly. And it mentions the word congruent, so we must remember that that means identical lengths and angles. Because it's asking us to prove, then for congruency we have to either prove we're dealing with side angle side triangles, or angle side angle triangle, or side 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 triangle, or right angle hypotenuse and side. So if we can prove that the side angle side works, or an angle side angle works, or that the triangles have all the three same sides, or we've got a right angle triangle where the hypotenuse is known and one of the other side lengths, then that one's proved through Pythagoras, because if we know that and that, then that fixes that to be whatever it is by the Pythagoras rule. So we've got to prove one of these conditions to show whether the two triangles are congruent. So we're dealing with triangle ABD, so A to B to D, and we're dealing with a circle, so it's likely to be we're going to use some circle theorem proofs, which we can assume. We're told that the diameter is AOC and BOD, so straight away, because of the diameters being given, it's about circle theorems, then ACD, that means that that angle there is 90 degrees, angles in a semicircle. So again, when you're proving things, you must give reasons. So angles, angle is angle. Angle in a semicircle at the circumference equals 90 degrees. So we've given the reason why we chose 90 degrees there, and again, for the same reason, that'll be 90 degrees there. Now, my recommendation when you're doing proofs with triangles and things is to draw out the two triangles separately and then prove what we've got. So that triangle ABD, and then we have triangle ADC. Well, we've proved the angle at D in this triangle is a right angle, and we've proved that the angle here is also a right angle. So we draw the two triangles out separately, and we've proved that those two are right angles. The question told us that the diameters are AOC and BOD, so that's BD and AC. So we know that BD is equal to CA, diameter of the circles are, it's a circle again, equal. So we've got a right angle, we've got a side, and it happens to be the hypotenuse. So if we can prove that one of the other side lengths is the same, then we could use the RHS approach. We've got an angle, and we could try and prove that some of the other angles are the same, and then we could work with side angle side or angle side angle. So let's have a look. Can we prove anything about the other lengths? Not really at the moment. It's not an obvious one. So let's go for some circle theorem proofs. Well, we can see here that this angle here must be identical to this angle here, because they're angles coming from the same arc, or angles in the same segment, are equal. So we know that the angle ABD is the same as the angle ACD. So we can say that angle ABD equals angle ACD, and we can use the proof that angles in the same segment are equal. So that's got those two angles. So have we now got enough to show what's going on? Then we've got an angle, we've got a side. Well, we know then that this angle here has to be the same as this angle here, because angles in a triangle add up to 180 degrees. So angles are equal. Angles in a triangle add to 180 degrees. So again, we're giving reasons why we've chosen all of those. So basically it looks like we've proved angle side angle because we've got the same angles and the same side length between them. So we can say here that ASA proved in both triangles, therefore they are congruent. So that would be enough to get the marks for the question, because we've gone through and we've shown through the circle theorems and through the idea of the angles in a semicircle being 90 degrees, the angles in the same segment are equal, and the fact that these are both diameters, then we've proved that we've got angle, side, angle. So we've proved that angle, side, angle is the same in both triangles, angle, side, angle. And we've written out the reasons why, so that should give us full marks in the exam for that question on congruency.